Hi guys, we're going to be sketching a curve using the first derivative. This is problem number 1. No calculators. You should be able to do this without a calculator. Now we're going to be given the function y equals x to the third over 3 plus x squared. Before we start using calculus, how can I use algebra? Well, what's the parent or basic function? This is cubic function. What will the graph look like? I call it Sammy the Snake. Here he is. There is your basic function. All right? Now, how else can I use algebra? Well, think about the domain. Are there any restrictions? No, there's no restrictions on a cubic function. Therefore, x equals all real numbers. Well, how about an asymptote? No asymptotes on cubic functions. All right? Now, how about your x-intercepts? Easy schmeezy, people. Set y equal to 0, factor it, come in, bam, bam. We now know that x equals 0, x equals -3. Well, what about the y-intercept? Yeah, we can do that too. When we do that, x is 0. Solve, y equals 0. What can I conclude? You now know that the x-intercept is -3, 0, and 0, 0. Hey, 0, 0 is also your y-intercept. We got 2 points. There they are. We're on a roll. All right, now let's talk about calculus. All right, you should already know how to do the first derivative. Okay, but what is the first derivative? Hey, it's the equation to find the slope of the function at any x value. All right? Now keep in mind, if the slope is 0, then the tangent line to the point is horizontal. And we have, yes, you have, a critical point. What's a critical point? Well, a critical point is an extrema. What's an extrema? An extrema is a max or a min. How do I find these points? You set the first derivative equal to 0. If the slope is 0, you have a max or a min. All right? Now, sometimes a critical point will be an asymptote, so be careful. Okay, finding the first derivative. You should be able to do this already. There is my first derivative for this function. All right, what do? How do we find the max or the min? We use the first derivative test. Okay, step 1. Set the first derivative equal to 0 and solve for x. What does this x value represent? The x value of a critical point. Okay? Now, let's do it. Here's my derivative. I set it equal to 0. I want to find where the slope is 0. I'm going to come in, I'm going to factor, I'm going to solve. I now know that the x values of the critical points are 0 and -2. Okay? I have 2 critical points. All right. Step 2. Now that you know the x values of the critical points, you can use the first derivative test to find if they are a max or a min. How do I do that? Draw a number line and plot the x values of the critical points on this number line. Now, what can I conclude? If the slope between the critical points is negative, then the slope is decreasing between the 2 points. If the slope between the 2 critical points is positive, then the slope is increasing between the 2 points. Huge, people, huge. You get this in your brain. All right, first derivative test in action. Okay, first thing we're going to do is we're going to put the x values for our critical points on the number line. Now we want to find if the slope between the critical points is negative or positive. The first interval we're actually going to look at is from -∞ to -2. What number can I pick? anything in there. I'm going to pick negative 10. Notice that all I care about is that it is positive. All right, now negative 2 to 0. I'm going to pick negative 1. It comes out negative. I don't care what the number is. All I care about is that it is negative. Now I want to look at the slope between 0 and positive infinity. I'm going to pick positive 10. Plug it in. Hey, this is definitely positive. Now, what can I conclude? Well, there is a maximum at x equals negative 2. Why? Because the function is increasing from from negative infinity to negative 2 and decreasing from negative 2 to 0. There is a minimum at x equals 0. Why? Because the function is decreasing from negative 2 to 0 and increasing from 0 to infinity. All right? Remember this. Now, we need to come back and use our original function to find the y values of my critical point. Well, my first critical point I'm going to look at is my maximum, where x equals negative 2. I'm just going to plug it back into the original function and find the y value. When x is negative 2, y will be 4 over 3. My other critical point is x equals 0. Again, plug it into the original function. I have 0, 0. Remember, that was my min. Okay, I now have my max and I have my min. All right, you are now have your critical points. You have your x-intercepts of this cubic function. It is time to graph this function, people. Let's do it. All right, start out with your x-intercept and your y-intercept. Okay, they're on the graph. Let's do our critical points. Bam, there they are. Notice that negative 2, 4 over 3 is a maximum. And 0, 0, which is our x-intercept, our y-intercept, and our minimum. Okay, keep that in mind. So from negative infinity up to negative 2, this function is increasing. When it gets to negative 2, it goes down to 0, 0 because that's my min, and then back up to infinity. All right, let's see what it looks like. Bam! There we go. We've done it. Now, let's do a little review. How can we just use algebra? Well, use the parent function to decide the overall shape of the graph and think about the end behavior. Find the restrictions on the domain. Find if there is any asymptote. And easy schmeezy x and y intercepts, right? Calculus, this is the new stuff. You can use the first derivative equation to find the x values of the critical points by setting the first derivative equal to 0. You can find if the function is increasing or decreasing between the critical points using the first derivative test, right? This will determine if the critical point is a max or a min. Then you have to go back to the original function to find the y values of your critical points so you can graph them. I hope this helped you. Now, there is sketching a curve problem number 2. It's harder. It's going to be rational. It's going to have restrictions on the domain. Yes, it has asymptotes. Yes, there is a first derivative test, and we will learn how to use the second derivative test. Okay? Have a great day. Bye, guys.